as now considering a anyone having the values v1, resolve the velocities of three components vx1, vy1, vz1, xyz axis respectively as shown in figure. Here what it is, my direction perpendicular to face abcd on striking the face with a velocity vx1 rebounds with the same velocity in the opposite direction. The change in momentum of the molecule per collision, the change in momentum of the molecule per collision is mvx1 minus mvx1, that equal to 2mvx1. 2mvx1 is the change in momentum. Here, according to Newton's second law, what it is, my force is equal to momentum by time. Change in momentum by time is called force. Therefore, 2mvx1 by delta t, then equation 2 అనుకుంటాం. ఒక equation. The time taken between two successive collisions is delta t is equal to 2l by vx1. So substitute 3 value in 2. Then what it is, fx1 is equal to 2mvx1 by delta t. Delta t value 2l by vxn, then it becomes m vxn పైకి పోతుందమ్మా, then mvx1 square by l అవుతుంది, equation 4. ఇట్లా n నెంబర్ ఆఫ్ పార్టికల్స్ ఉంటే ఏంటన్నమాట మొత్తం యాడ్ చేస్తాము, mvx1 square by l plus mvx2 square by l plus mv square x3 so on, అట్లా mv square xn by l అవుతుంది. అన్నిట్లో m by l కామన్ ఇస్తే vx1 square plus vx2 square plus vx3 square so on vxn square అవుతుంది. ఇక్కడ అన్నిట్లో n మాలిక్యూల్స్ ఉంటాయి, n ఇంటూ స్మాల్ m బై l ఇంటూ vx1 స్క్వేర్ ప్లస్ vx2 స్క్వేర్ సో ఆన్ vxn స్క్వేర్ బై n అవుతుంది. n ఇంటూ m బై l ఇంటూ ఈ మొత్తాన్ని మనము ఆర్ఎంఎస్ స్క్వేర్ గా రాయొచ్చు అనమాట, v బార్ x స్క్వేర్ అని. v బార్ x స్క్వేర్ ఇస్ ఈక్వల్ టు vx1 స్క్వేర్ ప్లస్ vx2 స్క్వేర్ సో ఆన్ vxn స్క్వేర్ బై n అవుతుంది అనమాట. ఇన్ ద ప్లేస్ ఆఫ్ దట్ వీఆర్ సబ్స్టిట్యూటింగ్ vx bar square ma, therefore the pressure exert on the face abcd is P is equal to pressure is equal to force by area. Area means length into length. Therefore, F by L into L, nothing but F by L square. Equation number 6. Now substitute equation 5 in equation 6. Then what it is, P is equal to F by L square. No, F and N undi, N into M by L into Vx bar square. Ikkada L square undi. Multiply cheste N into M by L cube into vx bar square అవుతుంది. therefore p is equal to nm by l cube అంటే ఏంటి, వాల్యూమ్ ఇంటూ vx బార్ స్క్వేర్ అవుతుంది. దాన్ని ఈక్వేషన్ 7 అనుకుంటున్నాము. ఇట్లా మనము vx బార్ కనుక్కుంటే ఇట్లా వచ్చింది. అదే విధంగా v by vz అని అనుకోవచ్చు కదా. therefore as the particle of velocity in 3 directions, hence c bar square is equal to vx square plus vy square plus vz square అవుతుంది. మొత్తం యాడ్ చేస్తే 3vx స్క్వేర్ అవుతుంది. vx స్క్వేర్ ఇజ్ ఈక్వల్ టు vy స్క్వేర్ ఇజ్ ఈక్వల్ టు vz స్క్వేర్ అవుతుంది. therefore vx స్క్వేర్ ఇజ్ ఈక్వల్ టు 1/3 ఇంటూ c బార్ స్క్వేర్ అవుతుందమ్మా. సబ్స్టిట్యూట్ దిస్ 8 వాల్యూ ఏదైతే మనం 7 ప్రకారం p ఇజ్ ఈక్వల్ టు nm బై v ఇంటూ vx స్క్వేర్ అయింది. 3 ఇంటూ vx బార్ స్క్వేర్ అనేది c బార్ స్క్వేర్ అయింది. ఇప్పుడు vx స్క్వేర్ వాల్యూని సబ్స్టిట్యూట్ చేస్తే మనకి ఫర్దర్ గా వస్తుంది డెరివేషన్. ఓకే, సో vx స్క్వేర్ వాల్యూ ఎంతమ్మా, 1/3 c బార్ స్క్వేర్. దాన్ని పైన ఈక్వేషన్ లో సబ్స్టిట్యూట్ చేస్తే వీఆర్ గెటింగ్ ద ఈక్వేషన్ ఇస్ p is equal to nm c బార్ స్క్వేర్ బై 3v. ఇక్కడ nm అంటే rho, nm by v is equal to rho అని తీసుకుంటామా. therefore P is equal to 1/3 rho C bar square అవుతుంది. From equation 9, 1/3 PV. 3 PV is equal to NM C bar square అవుతుంది. 3/2 PV is equal to N అవుతుంది. ఇక్కడ 1/2 MC square is equal to kinetic energy కదా. Therefore 3/2 PV is equal to we are getting that N into half. రెండు డివైడ్ విత్ 1/2 తీసుకుంటారు. రెండు వైపులా కూడా డివైడెడ్ విత్ 2 చేస్తే we are getting 3/2 PV is equal to N into half MC square అవుతుందమ్మా. 3/2 N KBT is equal to N into K average అవుతుందమ్మా. ఇక్కడ ఫ్రమ్ ఐడియల్ గ్యాస్ ఈక్వేషన్ PV is equal to N KBT and average kinetic energy of the molecule KE average is equal to 1/2 MC bar square. Therefore KE average is equal to 3/2 KB of T అవుతుంది, which is equation number 11, where KB is Boltzmann constant. Kinetic energy average is equal to 3/2 of KB into T అవుతుంది, which is Boltzmann constant. నెక్స్ట్ మ్యాక్స్వెల్స్ లా ఆఫ్ డిస్ట్రిబ్యూషన్ ఆఫ్ మాలిక్యులర్ స్పీడ్స్. దీనికి కూడా ఈక్వేషన్ ఏంటి, ఎక్స్ వై జెడ్ యాక్సెస్ పరంగా తీసుకుంటాము. యు వి డబ్ల్యూ డిస్టెన్సెస్ లో డియు డివి డిడబ్ల్యూ 3 కాంపోనెంట్స్ తీసుకుంటాం. డియు డివి డిడబ్ల్యూ అకార్డింగ్ టు ద కన్సిడరింగ్ యాక్సెస్ వీఆర్ గెటింగ్ ఫైనల్ number of molecules according to Maxwell's is dnc is equal to 4 pi n into m by 2 pi kt whole power 3/2 e power minus of mc square by 2 kt into c square dc అవుతుంది. ఇక్కడ the gaseous system has molecules that are traveling with a wide range of velocity speeds. Hence the molecules are moving with all possible velocities from 0 to infinity. Therefore, according to Maxwell's, the number of molecules having velocities lies between C and C plus D is given this particular equation, D and C. After that, how it is varying according to the derivation we are giving. So continuation, consider an ideal gas equation. The vessel of volume V as shown in figure. Let n be the number of molecules per unit volume. Let a molecule move with a velocity c in an arbitrary direction whose components are u and v and w along xyz in all directions. ఇక్కడ సి స్క్వేర్ ఇజ్ ఈక్వల్ టు ఆల్రెడీ వి సైడ్ నమ్మ ఎక్స్ వై జెడ్ యాక్సిస్ పరంగా యూ వి డబ్ల్యూ అని సి స్క్వేర్ ఇజ్ ఈక్వల్ టు యూ స్క్వేర్ వి స్క్వేర్ ప్లస్ డబ్ల్యూ స్క్వేర్ అవుతుంది. ఇఫ్ ఎన్ యూ బి ద నెంబర్ ఆఫ్ మాలిక్యూల్స్ పర్ యూనిట్ వాల్యూమ్ హ్యావింగ్ వెలాసిటీ యూ, so c square is equal to u square plus v square plus w square. If nu be the number of molecules per unit volume having velocity u, then the number of molecules per unit volume having velocity is lying between u and u plus du is equal to nu du. Equation number 2. ఇక్కడ nu is equal to n of f of u అవుతుంది. The number of molecules per unit volume having velocities between u and u plus du is nu du. n of fu is du అవుతుంది. The probability of that molecule selected at a random will have the velocities lying between u and u plus du అవుతుంది, which is f of u du అవుతుంది. Equation 5. Similarly, probability for molecules with velocities lying between v and v plus du is equal to f of v dv అవుతుంది. డెరివేషన్ పార్ట్ ఉంటుంది ఇక్కడంతా. Probability of total P of A, B, C is equal to P of A, P of B, P of C కదా. F of U, F of P, F of W, DU, DV, DW తీసుకుంటాము. The number of such molecules per unit volume will be N F of U, F of P, F of W, DU, DV, DW అవుతుంది, which is equation number 9. These molecules are contained in the volume element DU, DV, DW in the velocity space as given in figure. These molecules have the resultant velocity c, so that the number of molecules n f of c dou u dou v dou w. From the equation 9 and 10, it can be written as f of u, f of v, f of w is equal to f of c, that equal to phi of c square, where phi of c square is constant function of c square అవుతుందమ్మా. The d of f of u v ఒక్కొక్కదాన్ని differentiate చేస్తే we are getting these equations అన్నమాట. సో దాని డిఫరెన్షియేట్ పై ఆఫ్ సి స్క్వేర్ ఇజ్ ఈక్వల్ టు కాన్స్టెంట్ కదమ్మా. ఆ ఫంక్షన్ డిఫరెన్షియేట్ చేస్తే డిఫరెన్షియేషన్ ఆఫ్ ఎఫ్ ఆఫ్ యూ, ఎఫ్ ఆఫ్ వి, ఎఫ్ ఆఫ్ డబ్ల్యూ ఇజ్ ఈక్వల్ టు డిఫరెన్షియేషన్ ఆఫ్ పై ఆఫ్ సి స్క్వేర్ ఇజ్ ఈక్వల్ టు 0 అవుతుంది. ఈక్వేషన్ 12. ఎఫ్ డాష్ యూ డియూ ఎఫ్ ఆఫ్ వి ఎఫ్ ఆఫ్ డబ్ల్యూ, ఎఫ్ ఆఫ్ యూ ఎఫ్ డాష్ వి డివి డిడబ్ల్యూ, ఎఫ్ ఆఫ్ యూ ఎఫ్ ఆఫ్ వి ఎఫ్ ఆఫ్ డబ్ల్యూ డిడబ్ల్యూ ఇజ్ ఈక్వల్ టు 0 అవుతుంది. డివైడింగ్ ఈక్వేషన్ 13 బై ఎఫ్ ఆఫ్ యూ ఎఫ్ ఆఫ్ వి ఎఫ్ ఆఫ్ డబ్ల్యూ, then f dash u by f of u du, f dash v by f of v dv, f dash w by f of w dw is equal to 0 అవుతుంది. From equation 1, it can be taken as for a fixed value c square is equal to u square plus b square plus w square కదమ్మా. దాన్ని డిఫరెన్షియేట్ చేస్తే మనకి ఏమొస్తుంది, 2u du plus 2v dv plus 2w dw is equal to 0 అవుతుంది. ఇక్కడ మొత్తం మీద 2 కామన్ తీస్తే u du plus v dv plus w dw is equal to 0 అవుతుంది. Multiplying equation 15 with beta, then beta u du plus beta v dv plus beta w dw is equal to 0 అవుతుంది. Substitute adding equations 14 and 16, then what we are getting f dash u by f of u plus beta u du. అదే విధంగా f dash v f of v plus beta v dv. f dash w by f of w plus beta w is equal to o into dw is equal to 0 అవుతుంది. ఈ మొత్తాన్ని ఈక్వేట్ టు 0 చేసినప్పుడు మనకి f dash u by f of u is equal to ఏమవుతుంది, మైనస్ bu అవుతుంది. అదే విధంగా మైనస్ బేటా u మైనస్ బేటా w, బేటా u బేటా v బేటా w విచ్ ఇస్ ఈక్వేషన్ నెంబర్ 18 గా డిరైవ్ చేస్తున్నాం. ఇక్కడ f dash u by f of u plus beta u is equal to 0 అన్నప్పుడు మైనస్ అవుతుంది. ఇటు వచ్చినప్పుడు మైనస్ బీటా u మైనస్ బీటా v మైనస్ బీటా w అవుతుంది. సో ఈక్వేషన్ 18 నుంచి f dash u by f of u is equal to మైనస్ బీటా u అంటే 1 by f of u డిఫరెన్షియేట్ ఆఫ్ f of u is equal to మైనస్ బీటా u అనమాట. దాన్ని ఇంటిగ్రేట్ చేస్తే log e of f of u is equal to మైనస్ హాఫ్ బీటా u స్క్వేర్ ప్లస్ log e of a అవుతుందమ్మా. డిఫరెన్షియేట్ చేసిన తర్వాత వచ్చిన వాల్యూ. ఈ మొత్తాన్ని సింప్లిఫై చేయంగా సో మనకి ఏమవుతుంది, log e of f of u మైనస్ log e of a is equal to మైనస్ హాఫ్ బీటా u స్క్వేర్ అవుతుంది. log of f of u by a is equal to మైనస్ హాఫ్ బీటా u స్క్వేర్ అవుతుంది. f of u by a is equal to e పవర్ మైనస్ హాఫ్ బీటా u స్క్వేర్ అవుతుంది. f of u is equal to a e పవర్ మైనస్ హాఫ్ బీటా u స్క్వేర్ దట్ ఈక్వల్ టు a e పవర్ మైనస్ bu స్క్వేర్ అవుతుంది. ఈ b is equal to బీటా బై 2 అనమాట. Similarly, f of v is equal to a e power minus bb square. f of w is equal to a e power minus bw square అవుతుంది. which is equation step by step 21, 22 అట్లా తీసుకుంటాం అన్నమాట. Hence, the number of molecules having the velocity component lying between u and u plus du, v and v plus dv, and w and w plus dw is given by dn is equal to na power 3 e power minus b into u square plus v square plus w square du dv dw అవుతుందమ్మా. ఇక్కడ నెంబర్ ఆఫ్ మాలిక్యూల్స్ పర్ యూనిట్ వాల్యూమ్ ఎంత n. therefore according to the definition of probability in infinity minus infinity to plus infinity, f of u f of v f of w is equal to dou u dou v dou w is equal to 1 అవుతుంది. Substituting equation 21 and 22 in equation 24, then we are getting a cube e power minus b into u square plus v square plus w square dou u dou v dou w is equal to 1 అవుతుంది. According to the definite integral, we are taking every term is equal. Then a power 3 5 by b whole power 3 by 2 is equal to 1. a is equal to b by pi whole power 1 by 2. అదే విధంగా a is equal to m by 2 pi kt. b వాల్యూ ఏంటనమాట, m by 2 pi kt whole power 1 by 2 అవుతుంది. Substitute equation 23 in this. Then dn is equal to n of m by 2 pi kt whole power 3 by 2 అవుతుందమ్మా. e power m by 2 kt u square plus v square plus w square. దాన్ని మనం dou u dou v dou w గా తీసుకుంటున్నాము. డెరివేషన్ కొంచెం లెందీనే ఉంటుందమ్మా. టెక్స్ట్ బుక్ లో కూడా ఉంది సేమ్ సిమిలర్ వే. సో ఫైనల్ ఈక్వేషన్ ఏమొస్తుంది అన్నమాట, సబ్స్టిట్యూట్ చేస్తే ఆల్ వాల్యూస్ dn is equal to n into m by 2 pi kt e power m by 2 kt into u square plus v square plus w square dou u dou v dou w. Equation number 26 అనమాట. The total number of molecules that lie in a speed range c and c plus dc will be obtained by the taking volume element as the space between two concentric spheres of radii c and c plus dc drawn from the origin. Therefore, volume of annulus is given by 4 by 3 pi c plus dc whole cube minus c cube, that equal to 4 pi c square into dc. Hence, dou u, dou v, dou w is equal to 4 pi c square dc. U square plus v square plus w square is equal to c square అవుతుంది. Substitute చేస్తే dnc is equal to n into m by 2 pi kt whole power 3 by 2 into e power mc square by 2 kt into 4 pi c square dc అవుతుంది. Therefore, dnc is equal to 4 pi n m by 2 pi kt whole power 3 by 2 e power mc square by 2 kt c square dc అనేది final equation అవుతుందమ్మా. This which is called Maxwell's law of distribution of molecular speeds in a gas. This equation represents Maxwell's law of distribution of molecular speeds in a gas. Therefore, f of c dc is equal to 4 pi m by 2 pi kt whole power 3 by 2 e power mc square by 2 kt c square dc. ఇది equation 28 అన్నమాట. Therefore, dnc by n is equal to f of c into dc అవుతుంది. Next, speed distribution curve. f of c dc is equal to 4 pi a cube e power minus bc cube c square dc అవుతుందమ్మా. Let bc square whole power 1 by 2 is equal to x. f of x dx is equal to 4 pi whole power minus 1 by 2 e power minus x square dx. ఇవన్నీ కూడా molecular speed of speed distribution curve related terms అన్నమాట. Next, we have the root mean square, most probable speed. ఇవన్నీ రూట్ మీన్ స్క్వేర్ వాల్యూ ఏమవుతుంది, సిఆర్ఎంఎస్ స్క్వేర్ ఇస్ ఈక్వల్ టు 3kT బై m అవుతుంది. అదేవిధంగా మోస్ట్ ప్రాబబుల్ స్పీడ్ ఏమవుతుంది, సిపి ఇస్ ఈక్వల్ టు అండర్ రూట్ ఆఫ్ 2kT బై m అవుతుంది. యావరేజ్ స్పీడ్ వచ్చేసేమో అండర్ రూట్ ఆఫ్ 8kT బై 5m అవుతుంది. ఇవి సిఆర్ఎంఎస్, సి బార్, సిపిఎం మీన్ స్క్వేర్, రూట్ మీన్ స్క్వేర్ అవన్నీ. నెక్స్ట్, ట్రాన్స్పోర్ట్ ఫినామినా. ట్రాన్స్పోర్ట్ ఫినామినా అంటే ఏం చెప్పామమ్మా, ఇన్ ఏ స్టడీ స్టేట్ ఆఫ్ గ్యాస్ ఈచ్ ట్రాన్స్పోర్ట్ లైక్ మొమెంటం, heat energy and mass would be balanced by an equal and opposite moment in the reverse direction. Transport phenomenon. In a steady state of gas, each transport like momentum, heat energy and mass would be balanced by an equal and opposite moment in the reverse direction, and as a result there would be no net transport. If the gas is not in a steady state and there are places of concentration of momentum or energy or mass in some region of the gas, hence momentum or energy or mass will be transferred from this region to another through molecular collisions. This phenomenon is known as transport phenomena. Viscosity, thermal conduction and diffusion, all three is called as transport phenomena. So first వచ్చేసి viscosity of gas. The components of velocity of molecules may not have same value. The components of velocity of molecules may not have same value in all parts of the gas. This results in relative motion of the gas layers with respect to one another. Now the layers moving with greater velocity transport momentum to the layers of lower velocity. This gives rise to the phenomenon of viscosity. అది ఫస్ట్ వన్. నెక్స్ట్ వచ్చేసి కండక్షన్ అండ్ డిఫ్యూజన్. దాని డెరివేషన్స్ ఉన్నాయి మీకు. డెరివేషన్ డైరెక్ట్ స్టెప్ ఇచ్చారు. ఫస్ట్ ఒకటి చేస్తే రిమైనింగ్ 2 అలానే ఉంటాయి. విల్ ఎక్స్ప్లెయిన్ ఫస్ట్ విస్కాసిటీ, దెన్ రిమైనింగ్ 2 యూ కెన్ ప్రిపేర్, దెన్ విల్ గో ఫర్ అనదర్ టాపిక్. Consider a gas in motion along a horizontal surface. Now assume the gas to be considering of layers over a horizontal surface OX as shown in the figure. So here what it is the velocity of the layer in contact with the wall of the surface is 0, and the velocity of the layers increases with increasing distance from the fixed layer. That is velocity gradient dou v by dou y. Consider a layer AB increases with increasing distance from the fixed layer. That is velocity gradient dou v by dou y. Consider a layer AB at a distance y from OX. Let V be the velocity with which the gas flows in this layer. Later, consider two layers CD and EF above the and below AB respectively at a distance lambda. Hence, the velocity of the gas in layer CD is equal to V plus lambda into dou V by dou Y. The velocity of the gas in the layer EF is equal to V minus lambda into dou V by dou Y. Therefore, the molecules of the gas above AB have a greater velocity and hence possess a greater momentum than those below it. Hence, some of molecules above AB move downwards, while some molecules below AB having lower momentum will be moving upwards, as there is no mass motion in the y direction. Only x-axis loone different layers తీసుకుంటున్నాము. AB, CD and EF. AB is above CD is there, AB below EF is there, below negative gradient, above positive gradient. V plus lambda into dou V by dou Y అవుతుంది. కిందకు వచ్చేసరికల్లా V minus
Hello, ma'am. Reminding.
So the continuation, the number of molecules crossing per unit per second, maybe up or down, is NC bar 6 ma. The total mass crossing unit area per second is MNC bar by 6. The momentum carried downward direction is P1 is equal to 1 by 6 MNC bar into V plus lambda into dou V by dou Y అవుతుంది. అదేవిధంగా the momentum carried upward direction is P2 equal to 1 by 6 MNC bar into V minus lambda into dou V by dou Y అవుతుంది. Therefore, the net momentum transferred per second is given by P2 minus P1. Therefore, 1 by 6 MNC bar into V minus lambda into dou V by dou Y minus 1 by 6 into MNC bar V plus lambda into dou V by dou Y అవుతుంది. ఈ రెండిట్లో కామన్ 1 by 6 MNC bar తీసేసి V minus lambda into dou U by dou Y, V minus V into lambda into dou V by dou Y అమ్మా. ఈ క్యాన్సిల్ చేస్తే మనకి మైనస్ ల్యాండా మైనస్ వి ప్లస్ వి క్యాన్సిల్ అయితే -2 ల్యాండా ఇంటూ డో వి బై డో వై ఉంటుంది. వేర్ ఎఫ్ ఈస్ P2 minus P1. ఎఫ్ ఈజ్ ఈక్వల్ టు -1/3 MNC bar lambda into dou V by dou Y అవుతుంది, which is equation number 1. We know that F is equal to minus neta into dou V by dou Y అవుతుంది, viscous force per unit area. Therefore, from equations 1 and 2, minus neta into dou V by dou Y is equal to 1/3 MNC bar lambda into dou V by dou Y అవుతుంది. N into neta is equal to 1/3 MNC bar lambda. Neta is equal to 1/3 rho C bar lambda అవుతుంది. From equation 3, neta is equal to 1/3 MNC bar lambda అంటే 1/√2 pi n d square అవుతుంది. Therefore, lambda is equal to 1/√2 pi n d square main free path. Neta is equal to MC bar by 3√2 pi n d square అవుతుంది అనమాట. So here neta is the coefficient of viscosity. From equation 4 and 5 and comparing rho and C is constant, hence neta is independent of pressure. Neta is independent of pressure and hence C is equal to root T and is directly proportional to root T. Let the coefficient of viscosity of a gas is directly proportional to the square root of the absolute temperature of the gas. So up to that, it is the thermal expansion of the gases law. We have to take the coefficient of viscosity, which is transport phenomena. Next is thermal conductivity. After that, diffusion of gases. These two derivations also similar to that of viscosity only. Next, thermodynamics. In that thermodynamics, we are having the definitions are thermodynamic system, what is the boundary, what is surrounding, what is open system and isolated system, closed system. If you know all these terms, we know that thermodynamic systems anamata. In thermodynamics, we have the finite quantity of matter or prescribed region in space upon with which attention is concentrated is called thermodynamic system. A gas contained in a cylinder with a movable piston is thermodynamic system. Thermodynamics is a branch of heat in which we study heat is in motion and the transformation of heat energy into mechanical work and vice versa. Next, boundary. The system is surrounded by an envelope is called boundary. Surroundings, the thing which is outside of the system and influence the behavior of known as surroundings. The system and the surroundings quite arbitrary. The behavior of the system can be described in terms of microscopic properties. Macroscopic properties describes the gross characteristics of the system. These also explain the average behavior of molecules of the system. These are the classical approachment of the system. These are measured directly by the simple mathematical formula. Here, pressure, volume, temperature, etc. are the macroscopic properties. Macroscopic properties describes the internal structure of the system. In this case, we study about the molecular level things. There are statistical approachment of the system, velocity, momenta, energy, etc. In general, the systems are of three types. There are open system, closed system, and isolated system. What is open system? A system in which both mass and energy transfer takes place between system and surroundings is called as open system. If the mass within system remains constant is called closed system. A system in which an energy transfer takes place between system and surroundings is called closed system. Energy transfer as work. Next, isolated system. A system in which there is neither mass nor energy transfer across the boundary is called as an isolated system. Properties of a system. Properties are the observable characteristics of a thermodynamic system. Every system has certain characteristics by which its physical condition may be described. Such characteristics are called properties of a system. Pressure, temperature, volume, etc. Properties of system may be divided into two types. One is intensive properties and extensive properties. What is intensive properties? The properties which are independent of the mass in the system are called intensive properties. Example, pressure, temperature, density, specific heat, etc. Next, extensive properties. The properties which are depend on the mass in the system are called extensive properties. Mass, volume, entropy, enthalpy, etc. When all properties of the system have definite values, the system said to be exist to a definite state. Properties are the coordinates to describe the state of a system. Next, change of system. Any operation in which one or more of the properties of a system changes is called a change of system. Next, path of change of system and the state passes through during the change of state is called path of change of state. Next, equation of state to zeroth law of thermodynamics, thermal equilibrium, isothermal process, adiabatic process. All these topics is there in this particular heat lessons, thermodynamics. Next topic in the zeroth law of thermodynamics. Here, what it is, two bodies A or B in thermal equilibrium. Two bodies A or B are thermal equilibrium with the third system C. Then A and C are also in thermal equilibrium. If two bodies A or B in thermal equilibrium and A and C are also thermal equilibrium, then the B and C also in thermal equilibrium is known as zeroth law of thermodynamics. Separately, A and B are thermal equilibrium, then automatically the first two A and C and B and C also thermal equilibrium is known as zeroth law of thermodynamics. The zeroth law of thermodynamics leads to the concept of temperature. Next, thermal equilibrium. Whenever there is no heat exchange between the bodies are said to be in thermal equilibrium. The temperature in all parts of the system is uniform and same that surroundings the system is said to be thermal equilibrium. Next, temperature. The property which attains the same value as that of other property, other body, when they are put in contact with each other for a long time is called temperature of a body. The property which attains the same value as that of other body, when they are put in contact with each other for a long time is called temperature of a body. Temperature is the physical property that tells whether a body is in thermal equilibrium or not with another body. Internal energy. Next, the energy possessed by a system due to its molecular constitution. The energy possessed by a system due to its molecular constitution and the position of these molecules is known as internal energy. The position of these molecules is known as internal energy. It is denoted by U. According to kinetic theory of gases, matter up to a large number of tiny particles called molecules. The molecules are in a state of constant rapid motion and hence possess kinetic energy. The total kinetic energy of molecules is called as internal kinetic energy. Due to intermolecular forces of attraction between the molecules, they have internal potential energy. The sum of internal potential energy and the sum of internal and internal kinetic energy is known as internal energy of the system. Here U is equal to UK plus UP. Internal energy is the state function and it's independent of path. It depends only on initial and final state of the system. Thermodynamical coordinates. The parameters pressure, volume, and temperature describing the state of the system. Here P, V, T are called thermodynamical coordinates or thermodynamical variables. Isothermal process. What is isothermal process, ma? When a thermodynamic system undergoes a physical change in such a way that its temperature remains constant, then the process is known as isothermal process. The change in known as isothermal change. The process in which the change in pressure and volume of a gas taking place at constant temperature is called isothermal process. In this process, the quantity of heat which is developed or lost is given out taken from the surrounding. Boyle's law holds good for isothermal process. Worked in an isothermal process. When 1 gram of molecule is taken, here formula we are getting W is equal to 0.23026 log E of V2 by V1 అవుతుంది. Work done in isothermal process expression we see once here. Work done in isothermal process లో DW ఏంటమ్మా PdV. The net work done by the gas during the expansion from volume V1 to V2 is W is equal to integral V1 to V2 dW, integral V1 to V2 PdV. That is equation number 2. Therefore, for an isothermal process, PV is equal to RT. P is equal to RT by V. Equation number 3. Therefore, substitute equation 3 value in equation 2. Then what it is, ma? For an isothermal process, PV is equal to RT. P is equal to RT by V. Substitute in above equation. Then work done W is equal to integral V1 to V2 RT by V dV. RT integral V1 to V2 1 by V dV into RT log E of V V2 V1. Upper limit minus lower limit. RT into log E of V2 minus log E of V1 అవుతుంది. RT into log E of V2 by V1, which is equation number 4. Therefore, W is equal to 2.3026 RT log base 10 V2 by V1 అవుతుంది. Equation 5. Now, isothermal process P1 V1 is equal to P2 V2 అవుతుంది. దాని నుంచి V2 by V1 is equal to P1 by P2 అవుతుంది, which is equation number 6. V2 by V1 బదులు P1 by P2 substitute చేసాను అనుకోండి మా. Then above equation becomes W is equal to RT log E of P1 V2 P1 by P2 log in base 10 గా మార్చాలంటే multiplying with 2.3026 అనమాట. 2.3026 తో multiply చేస్తే what you have the equation finally 2.3026 RT log base 10 P1 by P2 అవుతుంది, which is the work done in isothermal process. V2 by V1 లో ఫార్ములా వస్తుంది, P1 by P2 లో ఫార్ములా వస్తుంది యూజింగ్ బాయిల్స్ లా అన్నమాట. 2.3026 RT log base 10 V2 by V1. 2.3026 RT log base 10 P1 by P2 అవుతుంది. Adiabatic process. Next, what is adiabatic process, ma? When a thermodynamic system undergoes a change in such a way that its total heat remains constant, then the process is known as adiabatic process and the change is known as adiabatic change. The process in which the change in volume and pressure of a gas takes place in a thermally isolated system is known as adiabatic process. In adiabatic process, there will be any change of heat energy between the system and surroundings. In an adiabatic process, PV power gamma is equal to constant holds good ma. Here gamma is the ratio of specific heats of gas. Gamma is equal to Cp by Cv అవుతుంది. దాని నుంచి వర్క్ డన్ రావాలంటే ఐసోథర్మల్ ప్రాసెస్ అయిపోయింది. నెక్స్ట్ అడియాబాటిక్ ప్రాసెస్ వర్క్ డన్ అన్నమాట. Here gamma is equal to Cp by Cv అవుతుంది. And here holds good coil size PV power gamma is equal to constant. Then PV power gamma is equal to constant substitute చేస్తే we are in terms of P we have to take dW is equal to PdP. Then integral V1 to V2 dW, integral V1 to V2 dW ప్లేస్ లో PdV సబ్స్టిట్యూట్ చేస్తాం. For an adiabatic process, PV power gamma is equal to constant. Then P is equal to K by V power gamma, which is equation number 3. Substitute equation 3 in equation 2. Then what it is, my W is equal to integral V1 to V2 K by V power gamma dV అవుతుంది. Then work done, W is equal to K integral V1 to V2 V power minus gamma dV అవుతుంది. The final expression is like this much. W is equal to K into V1 to V2 V power minus gamma dV అవుతుంది. K into V power minus gamma plus 1 by minus gamma plus 1 అవుతుంది. ఇంటిగ్రల్ V power minus gamma అంటే లిమిట్స్ V1 to V2 ఉంది. K by 1 minus gamma అప్పర్ లిమిట్ మైనస్ లోయర్ లిమిట్. అప్పర్ లిమిట్ ఏంటి V2 పవర్ మైనస్ గామా ప్లస్ 1. లోయర్ లిమిట్ ఏంటి V1 పవర్ మైనస్ గామా ప్లస్ 1. సో 1 by 1 minus gamma into K లోపల తీసుకెళ్తే ఇన్సైడ్ ద బ్రాకెట్ K into V2 పవర్ మైనస్ గామా ప్లస్ 1 మైనస్ K into V1 పవర్ మైనస్ గామా ప్లస్ 1 అవుతుంది. 1 by 1 minus gamma K బదులు P2 V2 పవర్ గామా అండ్ P1 V1 పవర్ గామా సబ్స్టిట్యూట్ చేస్తే 1 by 1 minus gamma P2 V2 మైనస్ P1 V1 అవుతుంది. దెన్ ఇట్ బికమ్స్ బేసెస్ ఈక్వల్ ఉంటే పవర్స్ యాడ్ చేస్తాం కదా, గామా మైనస్ గామా ప్లస్ 1 గామా మైనస్ గామా క్యాన్సిల్ అవుతుంది. P2 V2 మైనస్ P1 V1 అవుతుంది. P2 V2 అంటే RT2, P1 V1 అంటే RT1. సబ్స్టిట్యూట్ దట్ వాల్యూస్ అబౌవ్. Then W is equal to 1 by 1 minus gamma RT2 minus RT1 అవుతుంది. R by 1 minus gamma T2 minus T1 అవుతుంది. R by 1 మైనస్ గామా ఉన్నప్పుడు T2 మైనస్ T1 అవుతుంది. మైనస్ కామన్ తీసినప్పుడు R by gamma minus 1 T2 minus T1 అవుతుంది, which is the work done in a adiabatic process. Next, first law of thermodynamics. First law of thermodynamics, the amount of heat supplied to a system, is equal to the algebraic sum of the change in internal energy of the system and the amount of external work done by the system. It is known as first law of thermodynamics. Delta Q is equal to delta U plus delta W. Delta Q is equal to delta U plus delta W అంటే PdV. In general, when delta Q is the quantity of heat supplied to the system, apart it is used to increase its internal energy du, and the rest is used in doing external work dW. Therefore, dq is equal to du plus dw is nothing but first law of mathematical expression, first law of thermodynamics mathematical expression. What it is, dq is equal to du plus dw. Here, when a definite amount of work is done, then certain amount of energy is produced and vice versa. W is directly proportional to H. W is equal to JH. J is nothing but constant mechanical equivalent of heat that is equal to 4.2 joule by calorie. 4 joule by calorie. Isothermal process. In case of isothermal process, the temperature of the system remains constant. Hence, it is internal energy is constant. U is equal to constant. Du is equal to 0. According to first law of thermodynamics, isothermal process we are applying means du is equal to 0, then dq is equal to dw అవుతుంది. According to adiabatic process, what it is marked, q is equal to constant, then dq is equal to 0 అవుతుంది. Any places where q value same means dq is equal to 0. Therefore, according to first law of thermodynamics, dq is equal to du dq is equal to du plus dw. Dq is equal to 0 means du plus dw is equal to 0. Du is equal to minus dw, which is adiabatic process work done for first law of thermodynamics. We'll continue next class, reversible second law of thermodynamics and entropy.